MACRO VIC is a macro written in Python to be used in SDS2 as a tool to add any type of material on any member of the model. It is developed in 3 steps. First, the definition of the role or function that the material is going to perform, the second the location on the member where it will be added, and the third the specification of the material to be added. To do this, the macro is organized around 3 basic windows. The first configuration window, the second covers both the selection of the role of the material and its location on the member, and the third the definition of the material. Here we will refer when we speak of members, almost always to a beam and occasionally to a column. Once the options have been chosen in the first configuration window, the second window is passed to the first part to select the role of the material, then to the second part, which is made up of 3 groups of information, related to the 3 dimensions of the coordinate system whose origin is located at the left end of the beam, and with reference to which the material will be added. These dimensions are, the x-abscissa that runs along the beam, the z-abscissa that goes through the beam, and the y-abscissa that goes through the depth of the beam. The location of each of the 2 points, the beginning and the end of the length of the material to be added, is determined exactly by 3 coordinates, 1 on each of the 3 dimensions. The first point is also constituted in the pivot point, where in turn another coordinate system is located, the one that corresponds to the material. For that reason it is the pivot point, around which the material could be rotated, in any of the 3 dimensions. This is extremely important to easily understand the use and operation of the MACRO VIC, since it incorporates one of the pillars of the SDS2 model, which defines a universal coordinate system for the model, one of its own for each member of the model, located at its extreme left, and one for each material, located at its point of origin. The 2 points that define the length of the material are called by SDS2, the working points of the material. SDS2, in the parametrics module, shows the profile, shape, of the members of the model, in a section of a W-beam, where it highlights the points of the contour of that profile that are relevant and calls them together point map, suggesting to use them as a reference in the parametrics. So the 3 coordinates of each work point are linked to the point map, the z on the width, the y on the depth, and the x on the axis of the beam. If both work points share the x-coordinate, then the material will be placed perpendicular to the plane of the web of the beam. If they have different x-coordinates, then the material will be arranged along the beam. Simple and clear. The corollary of this statement is that if the 2 points share the coordinates z and y, then they do not share x and the material is located along the beam, and if they do not share them it is because the material is perpendicular to the beam. Simple and clear. This step on the 3 groups of information in the second window, W2, that is, the definition of the 2 working points of the material is terminated with the approval of this window, an action that returns us to the model to select the member or the beam where the material will be added. This is done simply by pointing to it and clicking on it, to open window 3, W3, which is where the material specifications are selected. Window 3 has 4 groups arranged in 2 columns. The first, upper left corner, allows either the entry of the specification, or the selection of the material from the SDS2 materials file. If applicable, the positioning characteristics of the legs of the angles, channels or curved plates are also specified there. The other 3 groups present information about the material and the beam where the material will be added. The information displayed in the lower left group refers to the material and its location with reference to the ends of the beam, the number of equal pieces to be added, their length and the angle that forms its central axis with the web of the beam, that is to say with the beam axis. The other 2 groups display information from the beam. The dynamics of the MACRO VIC operation resides in a larger cycle that begins in window W1, where the options to be enabled for the execution of the MACRO VIC are selected, an execution that consists of a cycle between windows W2 and W3, in which is interspersed, so to speak, a visit to the physical model, like this, W2, model, W3, W2. This cycle allows entering the required values in W2, going to the model and selecting the beam, Going to W3 and selecting the material and reviewing the information about which will be the result of the operation, returning to W2 and making the appropriate adjustments, returning to W3, adjust if necessary and finally approve, and then observe the material added in the model. Following this, there are several options: either continue in the cycle, or remain in the model, perform some operations on the added material, such as editing, cutting, welding it, etc., and then restarting the W2 model W3 cycle, or stopping. Even in the case of stopping, and if the option has been enabled in window W1 before entering the cycle, a second cycle of operation can be started, called subsequent operations, in which the beams and materials that were intervened in the initial cycle are reviewed to carry out operations such as cuts, welds, holes and screws, etc., after which it is necessary to finish the execution. There is also the option to terminate this cycle, return to the W1 window and change the configuration to start a new larger cycle. The MACRO VIC is modal, which means that it can run normally, in the way described above, to add material that can be edited, inside the execution, after it, or outside of it, thanks to its interaction with SDS2. In the first case, in the second case to its temporary capacity to remember the operations carried out in the major cycle, or to the usual SDS2 tools in the third case. And it is modal because it can also be used in editor mode, in which case it can record a group of operations and store them under a recoverable name in a later execution, making it possible in principle, the production of dynamic assemblies, that is, assemblies that fit in real time at different execution conditions from those in which they were stored. SDS2 presents in the client properties a very powerful similar option, which was not available when MACRO VIC presented this option already in 2009. The mode characteristics are set in window 1, W1, or configuration. So MACRO VIC tries to propose a new vision of parametrics, making available to the user a very versatile and at the same time educational tool, which does not force them to know Python, but to know SDS2 well in depth. MACRO VIC is designed as an open architecture that makes it possible to grow around its basic structure, improving its capabilities and scope, which will only depend on SDS2 making sufficient tools accessible to parametrics, and feedback from users with suggestions and critics.